In Chapter 6, we talked about algebraic relationships with tables. So we're going to begin by reviewing what function tables are. A function table is a table of ordered pairs that follows a specific rule. This rule tells you what to do to the input that will result in the output. Remember, the input is also known as the independent variable, and the output is also known as the dependent variable. The output is dependent on what you manipulate to the input. Let's use this example. Let's say the output is 4 more than the input. To create a function table, you may do so either horizontally or vertically. Here is how a horizontal function table would look. You will have a rectangle split in half. Most likely the top will be the input, or the x value, and the y will be the output, or the y value on the bottom. This is not always the case for every single table. The way you can know if the top information is the x value or not is to see if it is the independent variable. If these numbers are things that you can manipulate and you have control over, then this would be the x, or the independent. The way to check to see if your bottom half of your table will be the y is to see if it is the dependent. If the bottom information depends on what you manipulate at the top, then that means the bottom is the dependent variable, or the y. This is also known as the input and the output. So let's use this phrase. The output is 4 more than the input. Okay? This statement right here tells us what operation we will be using. The words more than, or 4 more than the input, tell us we will be adding. Okay? So in this case, our output is dependent on what our input is plus 4 more. So our output is y. It is dependent on our input, which is x, plus 4. So we just created an equation to help us fill in the table. So let's say they tell us our input values are 3, 6, and 9. We would simply input these x values into our equation to find our y values. So for example, to find my matching y value, I would plug in 3 for x, add 4. This would then give me my y value. So 3 plus 4 is 7. So my y value is 7. The same thing happens here. You plug in 6 for the x value. My rule stays the same. I'm continuing to add 4 each time. So my y value is 10. And lastly, I plug in my x value. I continue to add 4. That's my rule. And therefore, my y is 13. Notice here, this equation is our rule. It tells us what we're doing. This also tells us the relationship between the x and the y variables. Our relationship in our tables that we'll be reviewing will either be through addition or multiplication. Because in this rule you're adding a number to x, that means this relationship is additive, which means you are adding a value to x. So the relationship between x and y is additive. Now let's look at a different example. In this example, it says the output is 5 times the input. Again, we're going to make a function table, but instead of making one horizontally, we're going to show an example of making one vertically. The idea is still the same. You need to create a rectangle going up and down, splitting it in half, with the top being labeled X and Y. Normally when we create a function table that is vertical, our X is on the left, which represents our independent variable, or our input, and our Y is on the right. This represents our dependent variable, or our output. So, again, we are going to pick out the key words in this verbal phrase to create an equation, or a rule. It says the output, which is the Y, is 5 times the input. Okay, if I deconstructed this sentence, this would basically say Y is 5 times the input. This tells us our operation. The input is X, and I am multiplying, because it says times, by 5. So my X, I am multiplying by 5 to then get my Y value. This is my rule. So let's say that our X values are 3, 6, and 9. We again would plug in our values for X in our equation that we just wrote. So, if our X is 3, we're going to multiply that by 5 to get our Y. 3 times 5 is 15. So our Y value for this pair would be 15. Then we would plug in our second X value. 6 in the place of X times 5. Our rule remains the same. We're still multiplying by 5. So our Y value will be 30. And finally, we plug in 9 for X. Again, we multiply by 5, and our Y value will be 45. Because our rule says we're multiplying by 5, if we consistently do that to each X value, that will result in our output for our Y value. So, in this case, our rule is going to be multiplicative because we are multiplying our X value by a number. This is the relationship between the X and the Y.